So here's a nice little introduction to what polynomials can do for us. Polynomials, you've been studying them for years now. X squared plus 5x plus 3, a parabola, x cubed, x to the fourth. They're just uh, monomials strung together. They all have to have non-negative exponents. So what we're looking at here on the screen is a graph that's not a polynomial. It's a trigonometric function. It's the cosine of x. And early on this year, we learned we could approximate cosine with a tangent line, which is a polynomial at any point we want. I'm going to pick x equals 0. So the tangent line approximation, which is a first degree polynomial, in this case it's 0 degree because we don't have the x, is this line. And if you remember what we did, this line has values very close to the cosine around 0. So it hugs the cosine graph very, very close. But you can see as we zoom out, it doesn't come close to the cosine of these values, and then it gets lucky over here, and so on. So we're going to use now polynomials of higher degrees to approximate this. So I just want to show you that. We'll talk about where these came from, but if you look over here on the second line, that's a parabola. It's a polynomial with a degree of 2. Watch how that approximates this graph. So now it starts hugging the cosine graph well beyond the point at x equals 0, so it's going to be a better approximation for a longer interval, which is nice. But obviously, it gets horrible down here. So we're going to up the degree to 4. So that graph looks like that, and now it hugs it for a longer interval. We could up the degree to 6. Hugs it for a longer interval. It gets bad over here, and so on. Here's the 8th degree. Here's a 10th degree. You can see how it just sticks with the cosine graph a little bit longer every single time. I even have this 12th degree here. It's sticking longer and longer. And finally, we have this 4th degree, or 14th, degree. That sticks very long. So, look, you can barely tell the difference between this graph and the cosine graph. So that's very interesting how polynomials can approximate non-polynomial functions like that. And you could probably guess if we take this up to the 202nd degree, it's going to approximate it even longer. And when you get to calculus 2, we're going to take this polynomial, we're going to make an infinite number of terms, and it's going to match up exactly with a cosine. So that's a little appetizer to what we're going to be doing next, which is Taylor polynomials. Very neat stuff. But as we start and as we get into this, it might look a little confusing, but basically all it is the equation of a tangent line. Tangent line approximations that we've already used, but now we're just going to, instead of using lines, use parabolas, cubic functions, and so on. So the next video will start us up with that.